Okay, hi. So in this video, I'm going to discuss the marriage model from section 9.1. And we're going to look at how we adapt it if we have some rates now not only dependent on time, but also dependent on the time that you have been in a certain state for. So that is called CT, which is the current holding time in a state. So I haven't drawn the whole diagram because I'm only looking at the page 28 question. So I've written down this last part of the question. It's part 3. And so we're not interested in death in this part, or I suppose we are. Let me just see, because we're interested in the probability that a person is married at time t if we know that they were divorced at time s. Okay, so the full diagram has arrows from all these states going to the dead state. Okay, but we're not interested in that right now, so we're just going to ignore that. Okay, so now the question is, what happens if this transition rate dt is no longer just a function of t, but it now also depends on how long you were in this married state for? And so we're saying that your rate of getting divorced is going to be dependent on how long you were in the married state for. That's the change that we're making here. Okay, so how do we use a timeline to answer this probability? Okay, so the first thing we do is we draw S and T. Okay, let me just draw it a little bit lower. Okay, so here's our time S and here's time T. Okay, now we are saying we want the person to be married at time T, and they must be married for at least W time units. Okay, so if we work backwards from time T, so if this is if this blue part of the timeline represents W, that part that I'm drawing in blue there. Okay, so that's W. Then this time point here would be T minus W. Okay, because that blue distance is W. So we want to be married here, and we certainly want to be married for all of W as well. Okay, so that's the idea. Okay, so when and we know that we're starting off in the state divorced. So what could happen is that we could go from divorced, we could go to married directly, or we could go to married and then back to divorced and then back to married, or we could go from divorced to married and then becoming a widow and then back to married. So there are lots of different possibilities to consider. So let's consider the event that we are interested in, which is that you married for this whole time on the blue part of this timeline. Okay, which means that you must have got married sometime before time T minus W. So let's call that last time that you got married. Okay, let's call that state K. So obviously this is going to be somewhere on this side of the timeline. So let's say it's here. Okay, and let's call this time, let's say that this is V time units away from time T. So in other words, let's say that the last time you got married was at time T minus V. Okay, so in other words, I'm going to redraw this married arrow here. We're saying that for this whole time here, we want the person to be in the married state. Okay, so, okay. Now V could be anything from W or going all the way up until any part. So V could be anything from here, could happen there, or it could be any time there. It doesn't matter. It would still meet the definition of the event we are interested in. So for simplicity, I'm just drawing it away from W, but it could be that V happens to be on W and we would still be okay. All right. So let's call the state that we were in just before we moved to the married state. Let's call that state K. Okay. So now what are the possible values for K? Well, as I've explained before, it could be that K could have been that we were in the divorced. I just want to do a highlighter here. So by the time K comes around, we could be in here, we could be in the divorce state. So K could be the divorce state, and you know, anything could have happened in between, but we could have landed up in the divorce state and then got married. Okay. Or K could be the widowed state. In other words, from the being divorced at time S, we could have gone somewhere like, you know, at some point before time T minus V, maybe got married, maybe got divorced again, maybe got married again, became a widow as an example. And the point is, at time T minus V, we could then go back up to being married. Okay. So the other possibility for K is that K could be the widowed state as well. Okay. So the probability that we are looking for is, what is the probability that our life is married at time T, so xt is the married state, and we've been in that state for at least W time units. Okay, so in other words, our current holding time CT, which represents the time at time T, the time that it's been since the last jump. So in other words, we want that last jump to have happened at least W time units ago. So CT is bigger than W. Given that we started off in the divorced state. Okay. So we are going to integrate with respect to this variable V. Okay, so what's going to happen is that we're going to say this is equal to an integral of a whole bunch of things. This is going to be the integral of an expression, and we're going to be integrating with respect to V. So I'm just going to write dV there. Okay. Now, what do we want to consider here? We want to consider all the ways we could move before we get married. And then we want to consider staying married from time T minus V up to time T, which we can write as P M naught, because we're saying, you know, we want at time T minus V, we want the person to have just become married. So because now the rates are also dependent on the current holding time, we're going to say M naught to M bar, because we want to stay in that married state from T minus V up until time T. Okay, so let me just create some space there. from t minus v up until time t, and we are integrating with respect to v. Now, what are the values that v could take on? Well, v could take on, as I said before, we are fine if v is right there on w, it would still mean, remember, v is the time, the last time we got, the person got married. So the last transition to married. So v can be anywhere from w up until the full length of this so v can be anywhere from this length here, which is w, up to the full length, which is t minus s. Okay, so the range of values that v could take on is from w up until t minus s. And what are all the possibilities that we want to cover? Well, we want to cover that between time s and time t minus v, between these two time points here, we want to cover the possibility that we started off in divorce and ended up back in divorced, and then transitioned to married at time t minus v. And we also want to consider the probability that, or rather the path where we moved from divorced to widowed in between time units s and t minus v, and then we transitioned to married at time t minus v. Okay, so those expressions are simply the divorce to divorce part will be the probability of going from divorced to divorced between time s and time t minus v. And then we want to transition at time t minus v to married, because we're saying that v represents the last transition to married. And so that transition in the diagram is rho. Okay, so that would be rho, which is the force of transition from divorced to married at time t minus v. Okay, and then the other possibility that goes in here is the probability that we went from divorced to widowed from time s to time t minus v. And after landing here, we want to transition to married, which is the R, probably for remarried. Okay, so we go back here and we say it's this probability multiplied by R of t minus v. And that gives us our full expression. Okay, so these are the exact probabilities and the transitions that are happening if we consider all the possibilities for v, which is anywhere from w up until t minus s. Okay, and that covers how we got the expression for this probability on page 28 of chapter 5. Okay, please note that this M naught here is just a way of saying, well, at this time, we had 0 time in the married state at time t minus v. And the reason why we needed that is because now we have rates that depend on the current holding time in the married state. Okay, that's it. Undo that.